This lecture is about the existence and uniqueness theorem for the first order ordinary differential equation. So how we are going to solve this? That the question number 1 is about, does the following initial value problem necessarily have the unique solution? So we have to find the unique solution, but first we have to check that is the existence and uniqueness theorem is applicable on this question or not. So the question will be given as dy by dx equals to x into square root of y minus 3, where the initial conditions are given that x is minus 2 and y is equals to 28. In order to find the solution, we have to find first that the equation has a unique solution. We will apply the existence and uniqueness theorem. And how we are going to apply that? First, we will put the function equals to f of xy, and we have to check that the function is continuous around the given interval. And as well as we have to find the derivative of this function with respect to partial derivative of this function with respect to y. And we have to check again that whether this partial derivative is also continuous around the given interval. Whatever the given interval is, here the given interval is minus 2 and 28. And then we will start the solution that this is the given differential equation and these are the initial conditions. So we put dy by dx equals to f of xy. It is equals to x into y minus 3 square root. And when we are going to put the initial condition that x equals to minus 2 and y equals to 28, we get minus 10. So this means minus 10 is a real value. And whenever we get a real value, this means that it is a continuous function around the given interval minus 2 and 28. But if we get this value as an undefined function value, or if we get this as a complex number, so this means we will say that it is not continuous around the given interval. But as this is a real value minus 10, so we will say that the function f of xy is continuous around the interval minus 2 and 28. The next second step is that we are going to find that the partial derivative of this given function, it is also continuous with respect to y. So we will take the partial derivative of the given function where with respect to y, so x is considered to be as constant, so x will be same. But what will be the derivative of this? We will take 1 over 2 into y minus 3. So we take the derivative of y minus 3 will be again 1. So this means that the partial derivative of the function with respect to y will be equal to x over 2 into square root of y minus 3. And then substitute these points at this function. So when we apply these initial or the given values of minus 2 and 28 in this equation, substitute them and we get the answer equals to minus 1 over 5. So this is again a real value. So this means that this function or partial f over partial y is also continuous around minus 2 and 28. But if this value is undefined or it is some complex number, then we will say that it is not continuous around the given interval. So since both the conditions are satisfied, so by the existence and uniqueness theorem, the solution of the given differential equation will be unique. Unique means that there will be just one solution. But we have to check also whether that if we solve this differential equation, whether we get a unique solution or not. How to find the unique solution is that we are going to change this equation in the form of separable equation, and we multiply both sides by dx over y minus 3. So when we multiply this given equation by dx over y minus 3 square root both sides, and we cancel out all the terms which we can cancel. So this and this will be cancelled on the right hand side, and we will left with 1 over y minus 3 square root dy equals to x into d of x. So this is the separable equation, that this is in terms of x and this function is just in terms of y and dy. Now integrate both sides and we get that when we integrate both sides, we are going to get on this side integration with respect to y and integration with respect to x. So on this side, we are going to get 2 into square root of y minus 3, and when we take the integration of x, so we get x square over 2 plus constant of integration, that is equals to c. Now apply the initial conditions that x is minus 2 and y is 28. Substitute them, and then we are going to get the value of c. The c will be equals to 8. Then resubstitute the value of c in this equation number 1. So we are going to get, it will be equals to 2 into square root of y minus 3 equals to x square over 2 plus 8. So dividing both sides by 2 so that we can get the value of y in the end. So we have to do some manipulation so that in the end we just left with the value of y. So we divide first both sides by 2. So we get this y minus 3 square root equals to x square over 4 plus 4. And then taking the square of both sides so that the square and square root will be cancelled out. So we will get y minus 3 equals to x square over 4 plus 4 whole square. So after that, we will get y equals to, take this 3 to this side, so it becomes positive. So if we get y equals to x square over 4 plus 4 whole square plus 3. So you can see that the solution of this, that we can see that the solution is unique, that we get just a single solution for the given differential equation. So this means that first we have to check that whether the existence and uniqueness theorem is applicable. If it is applicable, then it is for sure that we will get in the end a unique solution. But in question number 2, it is also same. Does the following initial value problem necessarily have a unique solution? So the question is this, and the initial conditions are given that x is 3 and y equals to 0. So in order to find that the given differential equation has the unique solution, we will apply the existence and uniqueness theorem. According to this theorem, if f of x and y is continuous around the given interval and partial f over partial y is also continuous around the given interval, then the given differential equation has a unique solution. So first we will check that the function, whatever the differential equation, we put it equals to f of x and y equals to x minus y over x minus 1 over y. So we substitute the value of y, x equals to 3, y equals to 0. So we get something, that something is dividing by 3 minus 1 is 2. So 2 divided by 0 is undefined. So this means we did not get here a real value or real valued function. So this means that f of x is not continuous around 3 and 0. So the existence and the uniqueness theorem failed here. So we cannot say that how many solutions will exist, because we cannot say it has a unique solution, because the existence and uniqueness first condition is not satisfied, that f of x and y, it is not continuous at the given interval. So we cannot say how many solutions will exist or whether the solution will exist or not also. So we will try to find how many solutions exist. In order to find that also, again, we are going to first find the separable equation. So multiply both sides by y dx. So y dx, so that these denominators are going to be cancelled. So we will get y into dx into dy by dx equals to multiply this side also by y dx. So in the end, we will get y dy and x minus 1 dx. This is the separable equation, and integrating both sides, we get y square over 2, and here also integrate x, we get x square over 2, and minus 1 integration will be x plus c. When we apply the initial condition that x is 3 and y is 0, we will get the value of c, the constant of integration. So when we substitute all these values, we get c equals to minus 3 over 2. When we apply or substitute this c over 2, c is equals to minus 3 over 2 in equation 1. So we get the equation something like this. Now we will find the value of y, that how many solutions or how many values of y we will get. So multiply both sides by 2. When we multiply both sides by 2, so these 2's will be cancelled out. So we get y square equals to x square minus 2x minus 3. And taking square root of both sides, because we want to get rid of this y square. So we get y equals to plus minus x square minus 2x minus 3. So we can see here that the solution is not unique. It is not one solution. We are getting two values of y, that one is with the negative sign and the other with the positive sign. So there exist two solutions of the given differential equation, and the both solutions satisfy the given differential equation. So once the existence and uniqueness theorem failed to exist, then we have to check again that how many solutions exist. So here in this case, we can see that when the existence and uniqueness theorem failed, we get two different solutions in this question. So the solution is not actually unique. And the question number 3, does this initial value problem necessarily have a unique solution? Now this is the third question. We will check again that is this question also have the unique solution or not. And the initial values are given, x equals to 3 and y equals to 2. Now, in order to find the first, we have to check the existence and uniqueness theorem is applicable or satisfied for this. So first we will find that we will put this as f of x and y. It is equals to y square into x minus 3. And the initial conditions are x equals to 3 and y equals to 2. So we substitute the value of x and y in this equation. So we get it is equals to 0. So 0 is a real value. So this means that the function f of x and y is continuous around this point 3 and 2. Now the second step is to find the partial derivative of this function with respect to y. So after finding, we have to see that y square x, it becomes y square x minus 3, or you can take as a product rule u into v also, that the first function into derivative of second plus second into derivative of first. So whatever the method you want to take derivative, you can take. And after that, we can see when we take the derivative of y square, we get 2y. And this is considered to be as a constant because x is considered to be constant if you are taking the derivative with respect to y. So we will get the answer to y equals to x minus 3y. So x minus 3, and after that we substitute the values of x and y, and in the end we get 2 into 0, that is equals to 0. This means that the partial f over partial y is also continuous around the point 3 and 2. So by the existence and the uniqueness theorem, the solution of the given differential equation will be unique. Now we are going to see that is the solution unique or not. So we have to check also. So in order to check, first we will change the equation into the separable equation form. So multiply both sides by dx over y square. So when we multiply both sides by dx over y square, we will get the separable equation form 1 over y square dy equals to x minus 3 into dx. Now integrate both sides and we get that 1 over y square integrate with respect to y, and x minus 3 integrate with respect to x. When we integrate them, we will get the answer equals to minus 1 over y equals to x square over 2 minus 3x plus constant of integration. To find the value of constant of integration, we apply the initial conditions x equals to 3 and put y equals to 2. When we substitute y equals to 2, x equals to 3, so we get in the end the value of c equals to 4. So then resubstitute c equals to 4 in equation 1. So we get the equation in this form. Minus 1 over y equals to x square over 2 minus 3x plus 4. After that, we have to find the value of y also. So just take the reciprocal of these equations and we get y equals to 2 over x square minus 6x plus 8. And in order to remove this y, we multiply both sides by minus. In order to get rid of this minus or the negative sign, multiply both sides with minus. So on this side also, we get a negative sign. So in this case, we can see that the solution is unique and it is the only solution for the given differential equation. So this is how we are going to see that If the existence and uniqueness theorem is satisfied, then the solution for the given differential equation will always be unique solution. But if the existence and uniqueness theorem is not satisfied, then the solution can be more than one solution, or can sometimes the solution does not exist also. It depends on the whatever the question is given.